Welcome, ladies and gentlemen. Today we're going to learn how to graph a quadratic equation. We're switching gears here a little bit. We've been solving quadratics the last 2 days. Now we are going to graph them. Please remember the standard form of a quadratic is ax squared plus bx plus c. You use that to do your puzzles when factoring trinomials. So examples would be something like, x squared plus 4x plus 2. Or something like x squared minus 6x, or something like difference of two squares. How about x squared minus 121? We are going to learn to graph these. So what you're going to see now is it's going to be y equals each of these, and now it's an equation that can be graphed. This looks like a curve. And you can see two examples of a curve down below. We have a sad face when a is negative. So if a is negative, then we have a sad face. Here a is positive, and we have a smiley face. That's typically fairly easy to keep track of if you just remember negative a, sad face, positive a, happy face. Minimum and maximum. The minimum and maximum is found on something called the turning point. Turning point. It's an important vocabulary piece. And what we mean by turning point, if we scroll back up and take a look at these two graphs, what you have is that right here, when x increases, y decreases, which creates this effect of kind of going down. So the more you move in this direction, which is x is increasing, the y value is getting smaller. Once you reach a point right here, then as x increases, y starts to increase. So y was going down until we hit that point, and then y starts going back up. So this point here is called the turning point. If we look at the sad face, as x increases, y is increasing, which makes the points look like we're going up. Then we hit something called the turning point up here, and now as x increases, y is going down. So the turning point is basically where kind of the things start changing directions. If you feel like you're walking up a mountain here in our left example, so you're climbing up this mountain, you're climbing up and it's hard, and you've got your backpack on and Sherpa's carrying your stuff, and then you get to the summit of the mountain. That is the turning point right there. And then you start working your way back down. Alright. When you're on your skateboard on the skate ramp, you start skating on down here. Let's see, here's my little drawing of the skate ramp. I got a sweet board. You go down to the bottom, and then you can feel that momentum change in your body as you go down and start working your way back up and preparing your next trick. The minimum is the smallest y value, and the maximum is the largest. They don't have both. So if I come back up here again, erase a little bit of this stuff, it gets a little messy, especially when I'm skateboarding. Alright. For our turning point here, this is going to be a maximum. It does not have a minimum value for y, because what you'll see here is these go on forever and we'd put arrows on the end. When a is positive, there's going to be a minimum value of y. You don't have both. You either have a maximum, that's a sad face, the turning point's on top, or you have a minimum, that's a happy face, a is positive, the turning point is on the bottom. Now, the minimum and the maximum are always on something called the axis of symmetry. So what the heck is an axis of symmetry? This is a formula. You see the formula for it here. You'll be required to memorize that formula, so it's critically important that you have it. So what do we mean by the axis of symmetry? Well, if you think back to what symmetry was when you were little, you talk about a butterfly having symmetry, or basically what you want to be able to do is fold the thing in half, and there's a line that when you fold it in half over this line, the two halves line up. So if I fold this in half, this side is going to go on top of the other side when I fold it in half. That line, that dotted line that I have there, is called the axis of symmetry. I'm going to abbreviate it right now, axis of symmetry, AOS, but that's the axis of symmetry, and the turning point is on it. The minimum for that graph is on it. Here the axis of symmetry goes right through the middle. It's a line, x equals 2, x equals 3, x equals -6, x equals something generally. This is our axis of symmetry, and the turning point is on it. It is found by using the equation x equals -b over 2a. So we have to graph one of these things. If we are lucky enough, and listen, this is actually a help. If we are lucky enough to be told we want to graph x between -3 and 5, that is awesome because we do not have to decide the values for our table on our own. Here we would go -3, -2, -1, etc. down to down to 5. I don't have room to get it on here right now, but that's what we would do. Okay, so we would continue, try to squeeze it in here, and those would be the x values we'd use. And of course our calculator is going to give us the values, and we'll talk about how to put this stuff in there. Alright, so let's take a look at these two sample problems here. We'll talk about it a little bit as I load up your calculator. We are going to graph it for the given interval. We are going to find the axis of symmetry. We are going to give the coordinates of the max or the min from the turning point. And once this is graphed, it's pretty darn easy to pull that off the graph. Okay? So if we take a look here, this says we're supposed to go from -3 to 5. This is going to become our x column, so -3, -2, -1, 0, 1, 2, 3, 4, and 5. We're going to put just the quadratic in here. This is for work. We're not going to do work in here because we're going to use our calculator to do it. And that's our y column. Now you can, just to show you what work would look like, do -3 squared minus 2 times -3 minus 8. 9 plus 6 minus 8 is 15 minus 8, which is 7. So -3 would be 7. And we'd plot -3, 7, 1, 2, 3, 4, 5, 6, 7 right there. Okay? But we do have technology for this, and we should be using our technology so that we can have more practice time. So let me clear this out. We want to put in x squared. So you hit the x key, this x squared key down below here. We'll put a little 2 up there, minus 2x minus 8. X squared minus 2x minus 8. I'm going to hit zoom standard, which is 6. And there's what the picture is going to look like. So you can see a happy face. Now, of course, A is 1, so it should be a happy face. And we need our table of values. So we go to the table. We're supposed to be graphing this from -3 to 5. You'll notice that I have decimals in there. I'm going to go hit second window, and I'm going to fix that. I'm going to start at -3, and I'm going to count by ones instead of counting by decimals. That makes a really messy table. All right, so let's see. -3, 7, -2, 0. I can actually pull this over here so I don't have to keep going back and forth. -1, -5, 0, -8, 1, -9. And then you'll notice there's symmetry in the table. We have -8, -5. If I come back in here and scroll down a little bit, you can just hit down arrow to scroll down. 4, 0, and 5, 7. 4, 0, and 5, 7. So I just start plotting these points. I got -2 zeros right here. -1. We have a mistake in here. This should be +7. I did graph it right, I just wrote it down wrong. So let me fix that, please. Just bear with me for a second. Alright, I got -1, -5 here. I have 0, -8. I have 1, -9, and then I come back up. Boom, boom. What am I at? I'm at 4, 0, and I'm at 5, 7. I draw a nice curve through here. Don't do dot to dot. Try to make it look curvy. You will lose credit for a dot to dot. It has to be curvy looking. Then we go ahead and label all these points. I know this is tedious, but you're getting credit for this. So you are earning points for doing this work, and it's certainly work you all can do. Alright. Oh, there we go. 3, -5, 4, 0, and then 5, 7. Alright, last but not least, we have to label the equation out here. We do want to put arrows on our axis. You can see I'm doing that now. And I'm going to write the equation out here somewhere. Y equals x squared minus 2x minus 8. So all those labeling points that you were concerned about in the last chapter are necessary. Now, because they told us to graph between -3 and 5, we don't put arrows on the end of our graph because they only want us to graph this much of it. That is a minor style thing that you need to be aware of. So you'll notice I erased the arrows because we're only graphing between -3 and 5. Okay? Now, part B says give the axis of symmetry. So for part B, I am going to take my equation x equals -b over 2a. I'm going to take my equation x squared minus 2x minus 8. A is equal to 1. And b is equal to -2. So I do x is equal to -2 over 2 times 1, which is 2 over 2. So x equals 1, which is over here. X equals 1 is the axis of symmetry. Last but not least, we are asked to find the max or min. Well, look at the turning point is right here. Okay? You see it's going down, it starts going back up. You'll notice the axis of symmetry is x equals the x coordinate of that point. That happens every time. The minimum for this is the y coordinate of the turning point. So the minimum is -9, and the problem is done. And that's how you do it. Moving on to our next example. Y equals -x squared minus 2x plus 3. They do not give us an interval to graph in for this particular problem. So we have to actually skip forward and do the axis of symmetry first. So if I get myself on B here, -x squared. So A is -1, B is -2, and then x equals -b over 2a is my equation. So I got -2 over 2 times -1. Negative times a negative is a positive, so I get +2 on top, -2 on the bottom, and x equals -1 is my axis of symmetry. That's going to go in the middle of my table. I can put my x in here, put all this stuff in here. In case I don't have a graphing calculator, I'm going to do the scratch work. I have it ready to go. Alright, so on either side of -1, -2, -3, -4. On the positive side, or moving to the right on the x-axis, 0, 1, and 2. So I go to my calculator. I go to my graph. And I clear this out. -x squared. Make sure it's a negative sign and not a subtraction sign, or it'll give you an error. -2x, or -2x, and then +3. Zoom 6 gives me a look at it. Now A is negative, so as you can see it's going to look like a sad face. I go to my table of values, and you'll notice that in my table -4 is the top value there. So I'm going to scroll up until I get -4 on my screen. I can drag this off to the side here for now so that I can kind of refer back to it without switching back and forth like crazy. So we got negative 5, negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, and 2, negative 5. So we plot these values, negative 4, negative 4, negative 5. So 1, 2, 3, 4, 5 puts us right here. Negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, and 2, negative 5. Right there. They did not tell us how much of it to graph. They didn't give us an interval, so we're going to graph the whole thing. We'll label the points. We got negative 4, negative 5, negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, and 2, negative 5. And last but not least, we're going to put the equation on here. Put arrows on your axis, label the x and y axis, but you can see this graph has that labeled for you. We already did part B. As you can see, the line that goes right down the middle of this is x equals negative 1. For C, we have to identify whether it has a maximum or minimum. Because it's a sad face, it has a max. And it is the y coordinate of the turning point. The turning point is negative 1, 4. So 4, or y equals 4, but basically just that y coordinate. 4 is the maximum. The instructor understands that that is a y value. You don't have to put y equals, and actually you're kind of discouraged from putting y equals for that. As you see, we're going to do some graphing, so you're going to need some graph paper, and I have that in class for you. Bring your own if you wish. Please remember money for your review book. We're going to be on page 519 tomorrow. Quiz on solving quadratics before we get going with this graphing. Have a wonderful night. We'll see you tomorrow.